All right, hopefully you guys can hear me here. Mic is on. We'll give it about a minute or so for everybody to come on in. Let me know where you're watching from today and how the weekend was. Let me know something here. That way everything is working out all right. I'll get it loaded up on the page. Today we're going to talk all about weather technology. In fact, this is going to be kind of an exciting 2 weeks here that we're going to be talking about weather because it's all going to be leading up to you putting a forecast together. That's right. I'm going to try to teach some building blocks of how a forecast is put together. And we're going to talk about weather technology. We'll talk about clouds and radar and satellite weather balloons and taking observations and eventually forecasting. That part will happen later next week. We'll get to that with the actually putting that weather forecast together. So over the course of this week and next week, we'll be working on that. So let me go ahead and load things up here. So just give me a few more seconds. While I'm loading this up, I did want to let you know that how many of you guys have seen the sunshine, hopefully, over the last couple of days? How many of you guys have seen some of the stars and even the moon? The moon was particularly bright this morning. I came out, the sky was clear as I was heading into work at about 3 o'clock or so early this morning. The moon very bright. And actually coming up for later tomorrow, we'll have the brightest moon of the entire year. So obviously we get a full moon about once every month. Some of those are called supermoons, where they're a little bit closer to the Earth compared to when the moon is a little bit farther away. And we'll go into one of those supermoons, but it is going to be the brightest full moon that we'll have of the entire season. The only problem, it's going to be clouding up. We'll have some showers and storms around the area with that. So today we're going to be talking all about radar and satellite here. And this is kind of the lineup of where we're going over the next few days. So we've got radar and satellite we're going to talk about today. So part of that weather technology series for us. And then tomorrow, computer models. So we do talk about this sometime on TV. They're like big, powerful super calculators that help us to project what the weather may do in the future. And I'm going to give you guys some of these websites so you can actually, anytime you want, can go and look at these computer models. I'm not going to keep it from you. I'm going to actually give you a couple websites you can play with it. There's going to be a lot of technical information on there. It might be too complicated to understand everything, but at least I can kind of show you what forecasters do and what they're looking at to look at the weather. And then Wednesday, we'll talk about the importance of weather balloons and observations, and there might be some homework, although it'll be fun homework on Wednesday leading into next week. Again, this is all going to be leading up to putting a forecast together, so certainly excited about that. All right, let's go ahead. I'll go over here. It's taken a while to load this up today on my other computer. I think we've got it here. All right, so we're good to go. Yeah, sounds good. We've got Archbold. I can only see a couple comments here, but it looks like it's working out. So, all right, so radar and satellite. Let's go ahead and I'm going to go over to the UTouch machine here and show you some of what, how this all works. And then I'm going to show you some of the tools that we've got here at the station. So when we're putting a forecast together, how many of you guys, think about this, how many of you guys have, you got a lot of time on your hands now? There's been a lot of you guys that maybe put a project together. How many of you guys have ever built something before? Now it may be something like Legos, right? A Lego house, or it could be something like building a birdhouse, or maybe helping mom or dad with a bench, or maybe there was a house project, something like that. Think of some of the tools that you use to put that together. And now with the Legos, it might be your hand. Your hand might be the tool to hammer that down, and you press it down right there and get it in place how you want it. Building a birdhouse, maybe it's nails, maybe it's a hammer, maybe it's a screwdriver, maybe there's some other tools that you've seen with a project before. Maybe mom or dad had to put a fence together in the backyard or something like that. What are some of the tools used for that? Now, we've got our own tools when we're putting a forecast together. Now, they're not a hammer, it's not a screwdriver, it's nothing like that, but we do have tools that help us out quite a bit, and we're going to be talking about all those this week. But I'm going to start talking about some of the fun ones today because we're talking about radar and we're talking about satellite. Satellite is like a big camera, essentially, that's floating in outer space, taking pictures of the Earth. And this is really kind of a neat thing that we get to go through. Radar is a newer piece of technology that helps us see where rain and hail and dust, sometimes even bugs are at. So there's a lot of fun stuff there. So satellite, this is neat. This piece of technology was a big game-changing piece here for us to be able to see what's going on. Basically, you've got this big machine here that's going and rotating around the Earth, and it's got lots of instruments all over the place with this, okay? And it's taking, in cases, some pictures of the Earth, and maybe it's taking a picture like this in this box, and it's going to send that image back down to Earth so we can see it. But it has a lot of different types of ways it can take pictures. Sometimes it's just the actual image of what it looks like. Sometimes we can use infrared to see other areas of clouds and maybe monitor the temperatures around the globe. There's a lot of tools, not just taking pictures, but there's a lot of different instruments weather-wise that this can do. And if it wasn't for this satellite imagery, if there's a hurricane out here in the middle of the ocean, we would never know about it. And in fact, that's how things used to be 100 and 150 years ago, roughly, when these big hurricanes would develop. We would know about them until they hit somewhere, and they did an incredible amount of damage. It was a lot worse back then than it is today. So satellite has really helped us out quite a bit, but it's basically like a big floating camera that's taking pictures into outer space and sending those back down. Radar is really neat technology too, and sometimes it's pretty mind-blowing of how this even came about. But you've got the little radar dish here. And you might see a dome where this little dish is inside it, but it rotates around, even though there's a dome outside of it a lot of times. But it sends little pulses of energy, okay? Kind of like a microwave. Microwave sends pulses of energy and it hits your food, and then it helps warm it up and it heats up your food. Well, we're not really heating anything up here, but we're sending out a little pulse of energy, and it goes out, goes out, goes out, goes out, and just keeps going until it hits something. And in this case, if it hits rain, it hits some of these little raindrops, and some of that energy will scatter. Some of it will go up here, some of it will go over here, some of it will just keep on going through. It'll find a way through the raindrops, and some of it bounces right back to the radar. And as it comes back, it hits the radar. So what this radar dish is doing two things. One, it's sending out a pulse of energy. Two, it's listening. So it sends out the pulse of energy, and then it's listening with its ear, right? Its ear is a little sensor trying to pick up on that pulse of energy. And if it does get that pulse of energy, depending on how quickly it gets it back, the frequency will be a little bit different with it, and it can calculate where it ended up hitting something. And it can calculate based on how much energy comes back, how strong that rain is. So if a lot of energy comes back here, that means there's a lot of heavy rain. Let's just imagine there's a brick wall out here, okay? And there's nothing it's going to get through. Radar's beam's going to go out, it's going to bounce right back. It's like throwing a tennis ball against a brick wall, and it's going to bounce right back, and you're going to get all that energy back to the radar. Well, in that case, all of the energy, or almost all of it, would be bouncing straight back. So if we have hailstones coming down in this storm cloud and tons of rain surrounding it, it's going to come back, and a lot of it's going to come back, and that's that purple shading that we see on the radar that indicates there's an incredible amount of energy coming back. Or for us, we can actually look at it and figure out that it's rain and hail. We can figure out how far away from the radar it is. So this is a really, really interesting and helpful piece of technology that we can look at to forecast where the rain is. Now, this is my hand-drawn picture that I've tried to do here of a storm cloud, and it goes clear up into the sky, almost 30,000 feet up. Here's the ground here, and here's my little radar dish. Actually, you can't even see it because I'm basically where I'm standing is where the radar dish is at. But when these little pulses of energy go up, they kind of slice through the cloud. So it's not just in one spot. The radar will send a pulse of energy up through the cloud. It'll move up a little bit, it'll move up a little bit, and it'll just keep doing that. So it's not only scanning where that rain is at, but it's kind of slicing these storms in several different layers, and it's able to scan what's happening, which is really important because then we can figure out not only where the rain and the hail is in that storm cloud, but we can figure out how things are evolving, how things are rotating. So this is what you may look at if you're looking at a radar. You see all these little boxes here, and all those little boxes are little math calculations that the radar has done. But you can see this is a lot of heavy rain, and like right in here, that's probably some small hail that's formed because we got some of that purple there. Again, it's like hitting a brick wall. Here's our scale up here. But look at the colors down here on the other part of the screen. It's like we've taken Christmas colors here, put it in a blender, and chopped it all up and mixed it up, and now it's thrown back on the paper. You got really bright greens in here, really bright reds, kind of all mixed together. And the brighter the color, the stronger the wind is. But if it's green or red, it lets us know it's either coming towards or away from the radar screen, and we can get an idea of how fast those winds are moving and to some extent what direction the winds are moving, which helps us figure out if there's rotation inside the storm cloud. In this case, it wasn't rotation. It was winds that were actually moving away from each other at about 100 miles per hour. And this created some extremely strong winds in that microburst, a downburst that came and hit the ground. Now, this is a tornado that's developed. So I'm going to go back. I'm going to pick a different color here that might stand out a little bit better here. We'll use purple. We got our hook here coming right into here. And this little dot here, kind of on the edge of that comma, that's where that tornado is at. And if we go over to the other part of the screen and we look at the same spot, we've got strong winds here. So my purple's kind of shading in where it's already purple here. So let me pick up, I'll go back over to maybe the yellow. But then right in here that I'm circling, that's that same spot where you've got that little comma right on the other side that I'm circling in, and that's yellow. That's letting us know we have, if you were to really zoom in there, you've got extremely strong, very, very bright reds and very bright greens right next to each other. This is a classic situation that's letting us know that there's a tornado that is likely there, or at least the environment is conducive for a tornado to develop. So this is how radar can help us out so much. Not only can it let us know where it's raining, where it's hailing, where there might be bugs in the sky, where there's all this other stuff that's going on that can be detected, but it can detect the winds and the motion inside of a storm and let us know where tornadoes are developing, where hail is at. Helps us out big time for severe weather. That really helps us out quite a bit. So I'm going to take you back over to the other screen because we've got several different things that we are looking at here when it comes to satellite. I'll start off with that. This is the visible satellite image that we look at, and this is literally, we're just looking at pictures of the Earth. This is what it looks like from outer space. So right now, we've got just a couple clouds out there. There's more to the west. There's going to be more that builds as we go throughout the day. I'm going to take you out to the big picture. This is the same thing, but look how all of a sudden we have no clouds, and then they just all show up. And the reason for that is that we're getting the sun to rise and come up over the horizon. And so as the sun comes up over the horizon, we're seeing those clouds as they begin to appear. Now, our map here, we're not looking down from space at what it actually looks like on that map. So the map's a little different, but the clouds that all of a sudden appear and form, that's what it actually looks like. Those clouds are what it looks like from outer space as it continues to go on. Right now, if you look out towards Seattle and Portland, clear on the corner of your screen, they don't really have a whole lot of clouds yet because it's still really early there in the morning and the sunlight is just starting to get to the point where it's starting to light those clouds up. Now this, it looks like a big mess. We got purples, we got pinks, we got all kinds of stuff all over the place here. And this is a different type of imagery. So this is called infrared satellite, and it's measuring it in a different way to where the satellite can actually detect these clouds in the middle of the night, which really helps us out, but it's also a little bit different. You see some areas that look like where there might be clouds, and in some cases there may not actually be. It's actually picking up where the top temperature is. So that's kind of a different way for it to look at clouds and where clouds may be at. So it helps us out really at nighttime to figure this out. Now this is one of my favorites. We don't show this too often on air, but look how cool this is. We've got the water vapor imagery, and where you have the oranges and the kind of yellow shading there, that's where that's really dry air that's kind of moving into the storm. And then where you see the blues and especially the white, that's a lot of humidity, and that's generally where there's cloud cover, but it also lets us know not only where the clouds are at a certain level in the atmosphere, but it lets us know where the jet stream is moving, where we could have some upward motion to help form more clouds, and also where dry air is kind of getting mixed in. So there's a lot that we can tell just by looking at this. And then going over to the radar picture, there's not a whole lot going on around the country, so I can't zoom in right now and show you where there's a lot of storms or anything like that happening where there's severe weather, unfortunately, because there's just not a whole lot. I can zoom in and show you a little bit, though. And the radar, this is pretty interesting because it's a national radar. But we showed you just one of those dishes, one of those satellite dishes, basically, that's moving around, sending out a pulse of energy and listening for it back. So how can we see the entire country at the same time? It's not from one radar. We've got more than 50, 60 radars across the country. And really, if you can include the ones that are at the airports, you're talking a lot more than that. And so now you're looking at, this is what's called a composite map. It's a map of all those radars, all those zones put on the same map all over the place. So we can look at basically anywhere in the country and get a pretty good idea what's happening. Now, there are still a few spots out west you get these big tall mountains, and that's a problem, right? You put a radar here, the beam goes up slightly because of the curvature of the earth. The beam goes up a little bit, but if the mountain's really tall, it's still going to hit the top of that mountain. So there are spots out west that it's really tough to get spots that you'll almost never find rainfall or anything like that. Now, again, there's a little bit of light snow there towards the parts of Montana. Is there snow somewhere in these mountains? Probably, but you're so high up and there's so few people that live out here, you probably aren't going to be able to see it because there's still spots in the country that don't have perfect radar coverage. You know what? Hawaii is another one. I don't know what we can find out here, but I think there are I could be wrong, but I think there are 2 radars out here. One is in Honolulu, but when you start getting really far out, Honolulu going all the way out to Kauai, that's 105 miles. You start getting out here, that's 150 miles away. That's really far away. Typically, you get more than about 50, 60 miles, and it gets really tough to see much of anything with the radar, let alone severe weather capabilities. It becomes really, really tough. So, yeah, there's coverage, radar coverage out here, but it's a problem. And then when you zoom in, you can see that these are basically, we talked about this. Hawaii is essentially little volcanoes that have blasted their way up out of the ocean. And so this is really, really tall spot here on Kauai. And even when that radar beam does hit it, a lot of times it's being blocked. So there's a lot of interesting things that are happening with that. So for radar, it's a really important tool, but it doesn't cover every single spot across the globe. And satellite does a really good job for most. And we have brand new satellites that just went up a couple of years ago that are now bringing better high resolution mapping that we've never had before, which is very helpful. But they also kind of hover close to the United States or the mid-latitude levels and get really good sampling. They don't do a very good job on the top of the Earth and the bottom of the Earth, the North and the South Pole is. And so sometimes it can be tough to get good information on those parts of the globe, and that's where a lot of the cold air likes to be. And eventually, if that cold air is moving and it's coming towards us, we want to know what's happening at every spot around the globe because it helps us to know what the weather's doing and how it can change and how it can evolve. So today, again, we talked about radar, we talked about satellite. Tomorrow we're going to talk about computer modeling, which I think I'm going to give you guys some websites tomorrow, and I'm going to show you how we work them behind the scenes here. So I think that's a really kind of neat, cool lesson on how we forecast the weather and what we can do with it. And if you guys want, you can go on these websites and kind of play around with it and look at how things change, like a behind the scenes stuff. This is stuff that we're looking at. So it can be a lot of fun. But again, this is all going to lead up to weather forecasting here coming up by the end of next week. So I'm really excited about that. And even on next Tuesday, where I think we're going to do a forecasting, kind of like a practice forecast, which should be a lot of fun too. So I'm looking forward to that. So fire away any questions you've got, whether it be about anything we talked about today, forecasting in general. I mean, even if we get ahead of ourselves a little bit, that's okay. We want to talk about earth science stuff from last week. We want to talk about severe weather stuff from the week before. Let's go for it. Let me know what you're thinking, what you want to know about, and I'll go through some of those questions here. All right, let me go ahead and refresh, but fire away with those questions here. All right. Waiting for my questions here to pop up. Let's see what we've got. Was bugs showing up on the radar last night? So bugs show up on the radar a lot of time. So here's what I'm going to do. I'm going to go back. I'm going to show you a picture once again of what the radar beam typically looks like, and I'll explain when we get to see those bugs a lot of the time. A lot of times we can see bugs. We can see wind farms that take place out on where we've got the wind farms. Well, let me take you back one more image here. And here's our radar again. Here's our little satellite dish. Here's the Earth, right? The farther away you go, eventually the Earth does curve. And it's because the Earth isn't flat, but you got to go out really far and you begin to see that curvature of the Earth. Well, you have the curvature of the Earth in play here. And the radar beam itself is just slightly above the ground. If we angle it flat, the problem is that it's going to run into buildings and stuff like that. So it has to be elevated very, very, very slightly above the ground so it can get to those clouds and get to where it needs to go. Now, if the air is really calm, like it is in the morning, like it was last night. So you were asking about, was there bugs on the radar last night? Essentially, the answer is yes, but I'm trying to explain to you why we could see bugs. We couldn't just see not only bugs, but we were talking about ground clutter was the majority of what was on the radar last night. So basically, the beam was going up like it typically does, and it was hitting a layer of some warm air, and then it was going back down to the ground. And so it was hitting things like bugs, it was hitting things like dust, it was hitting the ground in some cases, the trees, and just other random things that are next to the ground. So normally that beam goes straight up and no problem, but if the sky is really clear and the temperatures cool off quite a bit, the temperature near the ground is going to be colder than the air above it, and so there's going to be this warm layer. So let me turn on some red, and let's say that there's some warm air right through here, okay? This is some warm air. And this happens a lot at nighttime, especially if the sky is clear. This happens quite a bit. So now if my radar beam starts to go up and it hits that, well, instead of still going up, it's almost like taking a stone and skipping it into the water. All of a sudden, that beam starts to reflect down, and eventually, if it goes far enough, it may actually come right into the ground, or it hits these buildings, right? And that's that ground clutter that we see. So in that case, even if it were to rain, we'd still see some of those raindrops down here, but almost always it's not raining when we see the ground clutter and the bugs and everything else, because we've got this warm air that's situated here, and the radar beam usually comes down. It can happen, but it usually happens on other mornings for us. All right, so let me go back up and take a look here. Let's see, can a house stop a radar beam? No, not usually, and there's a reason that there's a couple things going on here. So I mean, I guess in theory, it might be able to partially block it, but that's not going to happen. And the reason why is that the radars are going to be up on towers, so they're already going to be up high, and they do a lot of planning before they build one of these things. They are not cheap when they build a radar, and so they want to make sure that that radar is positioned to where it's not going to hit stuff. They don't want it to hit things like buildings or anything like that, because we want to see where the rain's at, we want to see where the hail's at, and we want to know if there's going to be severe weather. So they already place it up high a little bit, and that angle of the beam of the radar is slightly going up. It's not even flat, it's slightly going up. That way, as we get away from the radar, it's going to be far enough above it to where you're not going to see anything. So eventually, the lowest beam of the radar is going to be, it's going to start off maybe 100 feet above the ground or wherever the beam's at, but it's going to continue to climb, and eventually it's going to be thousands of feet above the ground as it continues to go away from the radar. So question coming in from Jessica Smith's account, why use a color scale? So the color scale helps us know how strong that power is that's getting reflected back to the radar, which lets us know how heavy the rain is. So if we see a color scale and it's showing reds, then we know that that rain is very heavy. It's coming down really, really hard. If we're seeing purples, that's usually an indication not only is it heavy rain, but there's probably going to be some hail in that. In fact, we have different functions altogether to where we can kind of look behind the scenes and we can see the potential for large hailstones growing inside that storm. So that helps us out. And when it comes to rotation, those bright colors alert us real quick to say, hey, there's a problem here. There could be rotation in the storm. So we can look at that and understand what's going on with it. So that color scale really helps us out really much more quickly than what it would otherwise. Otherwise, it would just be, okay, it's raining or it's not. Or we would actually look at the raw math, which would be a lot harder to look at quickly and understand what's going on. So the colors, I love the colors. It really helps us out quite a bit. Can a radar track hurricane from 100 miles away? So yes, but this is why satellite is so important. So you can start to see the outer bands of that rainfall from a hurricane about 100 miles away. You can't go a whole lot more than that, though, and you're not going to get a real good idea of what's happening closer to the ground, because by the time you get 100 miles away, my goodness, you've got to be probably 2 or 3 miles into the sky at that point. So you're not at the ground, you're 2-3 miles into the sky. So you're still slicing at a part of that hurricane. You're still looking at that rain, but you're not looking at the rain near the ground. You're looking pretty far up into the storm. So you're going to start to get a different look, a different picture of what that hurricane is doing. You're not going to see the winds and the strength of it, all that stuff towards the surface. So once it gets beyond that, you're really not going to see much of it at all. That's why satellite is so important, and it's why hurricane hunters are so important. Talking about a cool job and kind of a scary one too. These are airplanes designed to fly into hurricanes, and that's what they do. And you may be thinking, why would you ever want to fly an airplane into a hurricane? You're right, that doesn't seem like a very good idea. But these special airplanes that fly into them are going right into the eye and all the way through it, and they're dropping kind of like a weather balloon with the weather instruments attached to it. But this is different. They're dropping them inside the hurricane, and they're getting incredibly important weather information out of it. And that information, when it comes to satellite, is key because we can see these things develop thousands of miles away, and without it, there'd be no way to track if the hurricane would develop, let alone where it would go. But that information is absolutely critical to forecasts. Without that information, the forecast accuracy wouldn't be anywhere nearly as accurate as what it is on the track and also the strength of where it goes. And so that helps people evacuate and get to where they need to go before that ever hits. What's the biggest thing ever caught on radar? So there's Seth asking this one. There's a lot of big things that we've been able to track on radar in all the different categories. So you get golf ball size hail. That's going to be really bright. That's going to be a big thing that's going to show up on radar. Some of the bigger tornadoes that we've had, the last real big one was a Lake Township one that was just about a decade ago. That showed up as almost a big bullseye around that storm where that was taking place. It was a classic supercell. So that was big in its own right, or in its own way. We've had, when we talk about bugs, since we were talking about that, the mayfly swarms are by far the most impressive bug swarm that we ever see on the radar, because when these things come out and hatch over Lake Erie, they're low enough where they hit that radar beam just about perfectly, and they just fill up the western basin of Lake Erie. It looks like a big storm is taking over the western third of Lake Erie when those things hatch. That is really crazy. Let's see. Is there always radar bugs at night, or can they be there in the light? So if bugs are going to do what they want to do, but if we're going to see them usually, if we're going to see them on radar and be able to detect them, usually it does happen more at nighttime. When that radar beam comes down a little bit, because big bug swarms are usually closer to the ground, and we have to have that radar beam kind of get bent a little bit, and where it's heading towards the ground or close enough to the ground where it can pick up on that. So the daytime, the bugs are still there. They're still flying around doing whatever they do. Also, we can see a lot of big flocks of birds, but usually we see those more in the morning versus the evening for two reasons. One, the bugs like to go after the birds to go eat them, and that usually happens around sunset or sunrise. But so especially sunrise, the radar beam's usually bent a little bit more down towards the ground, and these birds go out, and sometimes you see them from wherever they're going, and it almost looks like a ring, and they just expand on the radar screen as the birds are kind of going out in a big flock in all directions to go after those birds, which is pretty neat. Stephen asking, does 13 ABC have a radar? What happened to it? We do have a radar. We've got our own radar that's out in Oregon, out at our transmitter site. At the time being, that one is not functioning. It's got a part that needs to be fixed. So at this point, that one isn't currently spinning around and bringing us some data back. So we'll see if that changes down the road. Let's see. Any more? Let me know if there's any other questions here. Let me load up the latest here. Here's a good one too, from Jessica asking, how do you receive stuff from satellites? So not only is the satellites picking up all this information, but then they're able to send down a signal basically right back to Earth. So satellites are neat in that they're out in outer space at a certain point in orbit where we can also basically communicate back and forth with them. In fact, that's how a lot of we have been able to get a lot of our certain feeds here at ABC or any of the TV stations around the station, around the country for that matter, are able to get some of this information back and forth. So let's say New York has got some video of something that's happening there and we want to air it. Well, they'll send it up, beam up their video essentially to a satellite. It goes up to there and then is able to send it back down to us because they can't send it directly to us necessarily in that same regard because of the curvature of the earth and there's a lot of other things basically in the way. But if they send that signal straight up into space to a satellite, basically can send that right back down to us. So there's a lot of different ways that satellites are used other than just weather satellites. In fact, GPS is the same thing. If you want to plug in, mom or dad ever want to know how do I get to a certain location, or you want to go out to eat or go to the grocery store or find a friend's house, whatever it may be, you plug in that information on the GPS or on the phone, and it's going to give you this route of where to go and how to get there. Well, all that information starts with where you are first. And so your little GPS signal that's being tracked there is that little blue dot. Maybe if you go to the maps and you see it, that blue dot is your GPS signal, and all that is being figured out by your location basically on the phone, and there's a set of satellites in outer space trying to help figure out where all that's at. All right, looks like we've gotten through the rest of them here, so I'm going to sign off. But if there's any other questions you think of later, bring them tomorrow. We'll talk about it tomorrow. Tomorrow we're going to talk about computer models, and this is where things start to get a little more interactive. So I'm going to give you guys some websites tomorrow, kind of explain what it is, what we're doing to forecast the weather. Some of it is probably going to be too technical. Don't worry about that. I just want to give you guys kind of an idea of what we're doing behind the scenes. And as we continue to work through some of these weather tools, and then we'll talk all about observations and weather balloons, which this one's going to be interactive too. I'm going to have you guys actually do some observing of the weather. I'm going to give you a secret. It is really, really tough to come up with a forecast that is accurate, anywhere close to being accurate, if you don't know what the weather is doing right now. It all starts with what's happening right now, and even what's happened in the past over the last day or two to kind of get your mindset ready for what's going to happen in the future. So I'm excited. We're working through this, and any more questions you guys have tomorrow, bring them. 11 o'clock, same spot here, right on the 13ABC Facebook page.